Laparoscopic crisis simulation. Development of a low-fidelity vascular injury model. These are our disclosures. Major vascular injury is a rare but potentially fatal complication of laparoscopy. Preparedness to acutely manage this complication can be difficult to achieve during residency given its rarity. Our objective was to enhance resident preparedness in the management of laparoscopic major vascular injuries by creating a cost-effective, low-fidelity simulation model. To build our models, we used cardboard, press and seal, nasal cannulas, scissors, clear tape, a 15-quart Tupperware storage box, IV tubing, 500 milliliter saline bags, red food coloring, a syringe and needle, orange-colored plastic lace, red felt, a disposable OR bunny suit, cotton polyfill, skin-colored cotton fabric, and Velcro tape. In order to run the simulation, we used an FLS box, laparoscopic graspers, Ratex, scalpels, and laparotomy pads. The total cost of this model was approximately $20 to $25 per model. First, we cut the cardboard to fit the base of the Tupperware storage box, then covered the cardboard in press and seal so that the model could be easily wiped down and used again. Then we cut the nasal portion of the nasal cannula to create a bifurcation effect, then secured it to the cardboard with tape. We then used a hot knife to cut a hole into the Tupperware container. We used a sticker to help delineate the shape. Ideally, make the hole a bit higher than we did so that the fluid doesn't leak out of the box. We then placed the cardboard with the nasal cannula into the Tupperware. We then passed the end of the IV tubing through the hole in the Tupperware box and secured it alongside the nasal cannula. We cut a defect into the IV tubing using scissors. We injected red food coloring into the IV bag to simulate blood. We then attached the IV bag to the IV tubing. As you can see here, the red fluid will leak through the defect in the IV tubing to simulate a vascular injury bleeding. We then placed orange-colored lace into the box to simulate bowel. We covered the box in press and seal to simulate peritoneum. We cut a hole in the middle of the press and seal to make space for the camera. 2 pieces of red felt were placed below the level of the hole to simulate the rectus muscles. A rectangular piece of the white-colored bunny suit was used to simulate fascia. Cotton polyfill was then placed to simulate the subcutaneous layer. Velcro tape was applied to all sides of the box. Skin-colored cotton fabric was then placed over the box to simulate the skin layer. The opposing Velcro tape is then applied to the fabric to secure it to the box. Two holes are cut into the press and seal. Matching holes are cut into the overlying fabric. The ideal location of the 2 smaller holes are 4 centimeters from the lateral edges and 12 centimeters from the superior edge. Ports from the FLS box can then be placed into these 2 holes. This completes the making of the model. This model easily fits into an FLS box, allowing use of the model even if you don't have a laparoscopic tower available for simulation. The neoprene cover can be removed from the FLS box to allow use of this model. The upper portion of the FLS box can be elevated to place the model inside. Center the FLS camera over the hole in the middle of the model. We placed a binder under the model to allow the camera to fit deeper into the center hole to allow for a clearer image. Once you let the IV fluid flow, you can see the simulated bleeding through the defect in the IV tubing. Laparoscopic instruments can be placed through the ports to allow for manipulation of the bowel to visualize the vascular structures. Learners can attempt to control the bleeding laparoscopically. If a decision is made to proceed with laparotomy, the laparoscopic instruments are removed and the learners can slide the model out of the FLS box and onto an adjacent table. Learners can then proceed with a laparotomy, cutting through each of the abdominal wall layers in order to identify the vascular injury and control the bleeding. Learners will need to retract the bowel in order to find the bleeding vessel and apply pressure. In conclusion, this low-fidelity simulation can be economically reproduced and fit into a standard FLS task trainer. This makes it accessible to gynecology residencies as well as other surgical specialties. Simulation is integral in increasing exposure to improve confidence and knowledge when managing these potentially life-threatening situations. Thank you for your time.